So let me digress here to talk about process, not equipment. This is schematic. The real word curves wouldn't be quite this square, but this is the behavior of reactive magnetron sputtering, where all of these are as a function of gas flow, like oxygen gas sputtering aluminum to make aluminum oxide. When I start to sputter the metal, I'm at a very high sputtering rate. If I were trying to sputter aluminum oxide, it would be a low sputtering rate, maybe down here. So it turns out if I start sputtering the metal and introduce more and more gas flow, I will continue to sputter at this metallic rate up to a point, because all of the oxygen is grabbed by aluminum molecules. So it's gettering. It's grabbing, like titanium will getter oxygen and aluminum will getter oxygen. So it can take all the oxygen it gets up to this point. At this point it starts to poison and just drops like a rock down, because the whole surface gets poisoned, and now I'm sputtering aluminum oxide, not aluminum. So I've got to cut the gas way back to sputter off that aluminum oxide, and at some point I've cleaned the target off and it goes back up to the metallic rate. So I've got this big hysteresis here. Now, if I look at the chamber pressure when I'm doing that, as I come out here, the chamber pressure, and I'm putting more and more oxygen in, this comes up here happily, and it's just taking all the oxygen you got, so the pressure doesn't change until it poisons, and then it comes up. And in order to get back to the metal mode, I've got to come way down in pressure to this point, and then I'm back in the metal mode. Now, also, the power supply for the sputtering, the discharge voltage changes. So I'm in this metallic mode and I'm going along here happily, and all of a sudden it poisons and the discharge voltage drops considerably. And again, I've got to back up on the gas. When the fellows from Advanced Energy were here, they were talking about this and saying, we can sense when the target's poisoning by the voltage. And so we can use that as our signal to control the reactive gas flow. However, the reactive gas flow has to be very fast. Just a regular old mass flow controller doesn't respond that quickly. So the conversation was they were basically using a piezoelectric valve to very quickly change the oxygen flow and have a closed loop system to keep it right close to the knee of that curve. And at that time the mention was that Van Ardenne had such a valve or whatever, and so they were going to work with him. And I assume now that that's all, everybody's using Van Ardenne or whatever to get what they want. And here's a curve. I think this was actually from Advanced Energy, where this is the real change in voltage. And so this had a nice slope, so I can see the ability to do a good control on that and keep it right here at this stoichiometric aluminum oxide point.